So I have the assignments for this week. There's only one assignment, and there is an extra credit assignment as well. Let me get my door. Let's see, what time is it? 11:29. So I'll give it another minute to start. There, I think I can tip it down a little bit. Let me see. So here I have an hourglass, and that is filled with iron filings. And let's see the time. I don't know if you can see that. If I get behind it, maybe you can see it a little better. This is one of my toys that I like to have on the desk when you come in. Can you see the what's happening with the iron filings as they're hitting the bottom? They're standing up into little points. And let's watch this as I take it off the base. Oops, there we go. So let's take a look at the base. Indeed, that's a magnet. So that's one of my toys. It seems to be time, so let's go ahead and get started. What I wanted to go over today was some of the things on the phenomena list that you have for this week's assignment. So extra credit, I apologize. I did not make that clear when I originally posted it, but a student emailed me saying, is this extra credit? And so I made that clear. And that's due on Friday. All right. The waves and the world, that's the assignment that you have for this week. I'm counting that as a lab. And that is due Thursday. So you're doing some sort of a presentation format. You are not actually presenting anything to anyone at any time. But you're putting together your information as if you were doing a presentation, and there should be some sort of a hook in there to grab interest. Remember that you're writing to either middle school or high school age students, so you don't need a lot of technical jargon, but you do want information about the waves in that item. So you're not just doing a report, say, on cell phones, but what does that have to do with waves? Okay, so there are a lot of different directions that you could go in on that one in particular. Not Eric. Hi, how are you? Good to see you. And so I do want to go over some of the links that were in that document. So in the assignment, there's a document that lists a bunch of different phenomena that you could choose from if there's something else that you want to do your presentation on. And again, like I said, it's not a presentation that you'll be doing for myself or other people. It's the information that you put together in a format as if you were doing a presentation. So if there's something else that you want to do that on, just ask, send an email or a reminder or something like that. Just ask. And wait, can you see me? No, I can't see you. I'm sorry. But I'm saying hi anyway. So if there's another topic that you want to do that presentation on, just let me know, and it will probably work as long as that has something to do with waves. So let me, what I want to do, I am not able to show you my screen in YouTube. I was thinking about doing a Google Meet instead, but what I have is a second computer that I will have the videos on that I want to show you. And, oh, maybe if this one is going to come up. There. Got my pen. So this is my husband's computer. I wrote down the pin. Now I have to find that paper that I wrote it on. Well, there we go. I'm in. Let's see if I can get this computer pointed to this one and see what we'll get. Is it too close? Not close enough. All right, so let's go ahead and grab one of these. I did pull them all up, so hopefully. Now this one is about square waves. That's a really cool phenomena that happens in a few places in the world. You can see here, you have a wave that's coming in this direction, and there's another one that is perpendicular to that. Isn't that really cool? So that is something that happens in particular places. The undertow can be really dangerous. So you should find out what's going on with that. If you have an interest in that. Let me see, what's another one that I can do? Let's pause this so we're not listening to it. Here's the next one that I pulled up. And this is bioluminescence. Let me make this full screen and play. So some of you may have more of an interest in biology than in physics. So there are several things in here that are biology related. All the sciences overlap quite a bit. So this is plankton that do this. They collect the sun during the day, but they only glow at night. So there's a lot of information in this clip about bioluminescence, but isn't that beautiful? So it does have to be stirred up in order to see it. And that's something that's brought up in another video that was from, I think Apollo 13 is the movie that's from. Let's go ahead and pause that so that, oh, it's done. It's not going to go anywhere. Okay. So this is
good grammar and spelling
the movie.
But if you want to write essays that inspire, messages
okay,
that forge
so now we are getting
connections,
something from,
and emails that get the job done, you
is
need
that
to think
this
about
one?
more than just grammar and spelling.
I don't know where
This
that
sentence
audio is coming from.
correct, but it's
I knew
wordy
that would happen.
and hard to read. It undermines the writer's message, and the word choice is bland.
What's this one? That's the list.
Grammarly's cutting-edge technology helps you craft compelling.
Okay, so let's go back to this one. This was about Apollo 13, where
Apollo 13 Commander Jim Lovell has more time in space, almost 24 days already, than any other man.
The shuttle was stranded in space, and they did not have a filter so that they could continue to breathe oxygen.
they seem to work out. Is there a specific instance in an airplane emergency when you recall here? Well, I tell you, I remember.
So this was on TV that they had given an interview, and that's Tom Hanks playing the commander of the shuttle ship.
And my homing signal was gone because somebody in Japan was actually using the same frequency, so it was leading me away from where I was supposed to be. And I'm looking down at a big black ocean, so I flip on my map light, and then suddenly, zap! Everything shorts out right there in my cockpit. All my instruments are gone, my lights are gone, and I can't even tell now what my altitude is. I know I'm running out of fuel, so I'm thinking about ditching the ocean. I look down there, and then in the darkness, there's this green trail. It's like a long carpet that's just laid out right beneath me, and it was the algae. Right? It was that phosphorescent stuff that gets churned up in the wake of the big ship. And it was just leading me home. And now, if my cockpit lights hadn't shorted out, there's no way I'd have ever been able to see that. So you never know what events are going to transpire to get you home.
Okay, so that's about the bioluminescence of the plankton. That when the ship is going past, it churns up the water and causes that plankton to luminesce. And he was able to follow that trail so he could find the ship and land his plane. This is about gravitons. Now, when is this? This is 2015. In 2016, they actually had found evidence of gravitons. So they saw gravitons. This was filmed before that happened, so it was still theoretical, but now they're for real. So let's go ahead and make this large. Very exciting. Science changes very fast. There was something that I learned this year.
But it's gravity on a microscopic level that makes things more interesting. And here's a quick disclaimer. Before I dive into what gravity is on a subatomic scale, you might need some background knowledge of string theory. Anyway, there are two main types of strings, closed and open. An open string, just like the name suggests, is a string that does not close in a loop, but also an open string contains zero-dimensional particles at its end.
Uh-oh. What did I do? Because I moved the screen.
Points called D-branes. A closed string, again, just like its name suggests, is a string that's closed in a loop and does not have D-branes as its endpoints. Gravity is made up of subatomic particles, which are closed strings called gravitons. Because gravity is a closed string, it can do something pretty interesting. You can think of our universe like a membrane, or a brain for short. And most of the stuff on this brain, like you and me, are made of open strings which are permanently attached to the brain via the D-branes on their endpoints. So in simpler terms, most of the stuff you see around you probably won't be able to escape the universe because it's permanently attached to it. However, gravitons, as mentioned earlier, are closed strings. This means gravitons can leave our brain because they're not attached to it. And this can mean something very important. As you can see, string theory allows for the possibility of multiverses, or multiple universes. And every single one of these universes are brains just like ours. And as mentioned earlier, since gravitons are not attached to the brains, this means they can travel to other brains. Or in simpler terms, gravity can travel between universes. However, gravitons, just like photons, are massless particles and can travel at the speed of light. Unfortunately, the distances between universes are so large that despite the graviton's fast speed, it would take eons for gravitons to travel from one universe to another, which means we won't be detecting gravity from another universe for quite a while. In addition, how gravitons work is complicated but kind of interesting. To simplify it as much as possible, I'm just going to say that whenever matter and space interact with each other, they exchange gravitons, and this exchange of gravitons is what we perceive as gravity. But then this brings up another question. Is gravity a wave or a particle? Well, an article at Fermilab answered this question. In the article, it clearly stated, and I quote, "Gravity is a force. For all other forces that we are aware of, we have identified particles that transmits forces at a quantum level. In quantum theory, each particle acts as both a particle and a wave. So if there is a graviton, we expect it to behave both as a particle and as a wave." This whole idea behind gravitons is one of the best things that quantum mechanics has to offer us, in my opinion. But there's just one small catch. It is all just a theory. So we don't know whether
And that's not
gravitons
true.
actually exist or
That
whether
we
they
have
are
actually
myth.
seen them.
However, mathematically, gravitons
2016.
can exist. And so there you have it, the very, very basics of quantum gravity. Don't forget to like, share, and subscribe. And stay tuned for more science videos.
Okay, so that's why throughout the year I probably said something to the effect that there's no such thing as gravity, because it's not something that reaches out from an object and applies a force that's pulling a thing towards it. There are gravitons involved. There's the bending of time and space as well. Now, this is about this is a blind boy who can see without his eyes, so he uses echolocation. And I find this fascinating. Let me go ahead and escape. I want to turn the volume up a little bit more if I can. Like I said, this is my husband's computer, so I have no idea what to do. Nope, that's not it. I do not see it down here. All right. So we're going back here, go full screen, and play.
Both eyes were removed when he was 3, leaving him with no vision at all. So how on earth does Ben do this? And this? And
Do you hear that he's clicking?
I've never come across somebody like that. He is quite unique. Ben lost his eyes to cancer, but unbelievably, he's taught himself to see with sound.
If he chooses to go out there and ride that bicycle, let him ride the bicycle. It's got to be very smart. Somewhere in there, it's a little genius going on. I don't consider myself blind. Ain't nothing wrong with me.
Ben has no guide dog and never uses a white cane. He's not even using his hands. Instead, he sees with sound. He makes a sharp click which bounces back off nearby objects. Amazingly, Ben's ears pick up the echoes and he can precisely locate where things are. Ben is the only person in the world who sees using nothing but echolocation.
And that's not true. There are other people now.
I've been able to tell where walls are and where things on the ground are. If I click down, then I can hear them easier. But if I'm walking, I'm just clicking over it, it's not going to get it. And I can tell where desks are in the classroom and stuff like that. I can hear the wall over there, the couch over there. I can hear the wall behind me. I can hear the wall over there and the TV and the computer. Yeah.
Ben, I need a towel for drying because I don't have all my kitchen towels in here. All right, Mom, I'm going to go get it.
Ben's echolocation is so good that at home his mum, Aquanetta, Uncle Kerry, and brother Isaiah make no allowances for his blindness at all.
I don't even know if I can do that.
I just know he was my brother.
Did he make it? He's determined to do what he's going to do. And he refuses for somebody to label him as blind. You see this kid that has a whole different way of thinking. It's magic and it's real.
I don't think I've ever seen anyone quite as remarkable as Ben, nor have I seen anyone quite as remarkable as Ben's mom. And I think that's a lot of the secret to Ben's amazing talents.
He knows that there's nothing impossible for him. And it's not.
All right, very inspirational, isn't it? I think it's absolutely amazing. Oh, this one is really cool. This is Chladni plate. So the echolocation, that is sound going to an object and then bouncing back again. So that's in sound waves. This is a Chladni plate. Again, this is all about waves, frequency. Oops, I didn't make this big enough yet. So the sound, each sound has a different frequency.
For the cymatics music video is called a Chladni plate. A Chladni plate's basically a metal plate attached to the top of the speaker. There's sand on top of the plate, and you play different tones through the speaker. The plate vibrates, which forms different shapes depending on the frequency of the sound.
Well, we blew up a lot of speakers with the Chladni
and they
plate.
have this
So there was
the
a lot of experimenting
exploratorium.
around the Chladni plate, primarily looking at how much volume we can put through there, how much sand to actually put on the plate, and the different shapes of plates and what different patterns would be created because of those shapes. But what we were really testing was what frequencies create the most interesting repeatable patterns, because that was a key point. So we ended up playing pretty much every audio frequency through the plate to see what different shapes it would form.
And for most frequencies, it doesn't really do much, but when it hits a frequency that resonates with the plate, it forms a really nice pure shape. So we found out what those tones were, and those were the tones we used to draw.
That has everything to do with waves as well. That's cool. Waves moving through water as well.
Jenny?
This is the ThermX. So this is a medical technology. It's one of the newer technologies for battling cancer. This would be a technology that is used instead of chemotherapy. So if you want to find out about that, I don't have a video on it, but it's a ThermX. If you put in microwave, then it sends you to kitchen appliances. But if you put in ThermX, you can Google this up. I got a whole bunch more. Now this is about the sun. So here we see solar sunspots. And this is 2 minutes. Okay, I'll play this one. Will I get this bigger?
Sending a steady stream of heat and light our way. But how much and exactly what kind of energy and matter the sun releases changes all the time, depending on what's going on beneath its surface. This means the environment of our solar system is constantly changing, creating space weather around our planet. Like weather on Earth, solar conditions are moderate most of the time. Even though the sun belches out 1 million tons of energetic particles every second, this solar wind is so spread out, it's like a warm, steady breeze. But sometimes space weather can take a sudden turn for the worse. Violent storms erupt with the potential to cause serious damage. There are 2 main kinds of storms: solar flares and coronal mass ejections, or CMEs for short. Flares and CMEs are closely related and start the same way, with fluctuations in the sun's magnetic fields. These magnetic lines themselves are invisible, but we can see them light up as they channel bright, hot flows of solar plasma. The most common storms, solar flares, tend to be quick, powerful, and localized, like intense thunderstorms. They shoot high-energy particles as well as X-rays and gamma rays away from the sun at incredible speeds. A single flare can release the energy equivalent of 10 million volcanic eruptions, or more than 1 billion hydrogen bombs. CMEs are bigger, slower, and more spread out, more like a hurricane. These huge eruptions of plasma from the corona start out narrow, but they soon expand to about 30 million miles across and can travel at speeds of up to 4 million miles per hour. Like gathering clouds, sunspots offer a clue that storms might be brewing.
A sunspot is a massive region, several times the size of the Earth, which appears on the sun as a dark spot. It's dark because it's relatively cool compared to its surrounding. And it's cool because the magnetic fields are so strong that they're suppressing the flow of heat from below.
The sun sends storms out in every direction, and Earth is small and far away, so we're largely oblivious to all this solar activity. But a small percentage of solar storms do hit Earth, and when they do, they can cause serious damage.
Okay, so that's all about plasma and wrong one. Need to close
The sun has been shining brightly for more than...
Oh, this is another device that I typically have in the classroom. I brought it home so I could show you guys, but it's not easy to get the effects of this using my computer as my camera. So this is better. So look at that little red ball on top. But it's not on top. It looks like it's on top. Try to pick it up and you can't. There it is. It's because of the shape of the mirrors that are inside that it creates a virtual image that is right above the device. Okay, very simple device. So that's one that you can check into. This is about CERN. I don't think this is one that I had picked. Here's one. Let's see how long this one is. It's getting late. We've been at this for a while. Video unavailable. Okay. How about this one? Time travel.
Yes, it's possible, and they're doing it with their $10 billion particle accelerator.
Okay, this is about particle accelerators.
A couple years ago that got canceled. Basically, it
CERN is below ground level. It's below two different countries.
And it just got canceled because the power elite, they've got this thing where they
and that's a proton accelerator. Let's see what this is. Nope, that's my husband's stuff. Nope, don't need that. Don't need, oh, that. And then here's a magnetic field reversal. I don't think we'll watch that. Let's watch this one though. I don't think it gives us a good picture of what happens to Earth's magnetic shield when we're experiencing the solar winds. And what I found out this year is that the solar...
Our sun is constantly blasting huge amounts of hot plasma out into space. All those charged particles have a big effect on everything in their path. So what's protecting Earth from the solar wind and solar storms? Earth's thick atmosphere provides some defense, scattering and absorbing solar particles before they reach the surface. But our planet also has a secret weapon, a strong magnetic field it projects into space, mostly generated by molten iron alloys moving in Earth's outer core. The area of space where the magnetic field interacts with the solar wind is called Earth's magnetosphere. Its shape constantly changes as it's bombarded by solar particles. As positively charged protons and negatively charged electrons enter the magnetosphere, most of them are deflected around Earth, long before they reach the atmosphere. The magnetosphere really gets tested when big solar storms, carrying more plasma and traveling at higher speeds, are on a collision course with Earth. While most of the plasma is deflected, some of it gets trapped in the magnetosphere and funnels back toward Earth along field lines emanating from the poles. As charged particles from the sun collide with nitrogen and oxygen molecules in our atmosphere, they create the cosmic light shows known as auroras. The bigger the storm, the further from the poles auroras can be seen. Some storms are so big, they interfere with satellites, cause planes to alter their routes, and can create other problems. The vast majority of the time, these inconveniences are pretty minor, but the next time the solar version of a perfect storm overwhelms Earth's magnetic shield, we might not be so lucky.
All right, so that's pretty much what I wanted to show today. Yeah, let's go ahead and cancel that one out. All right, so what I did find out about the sun this year, I always learn stuff when I'm lesson planning, was that just like the Earth's magnetic field flips every 700,000 years or so, the same thing happens at the sun, only that happens every 7 years. It's a 7-year cycle. And when the field is in the same plane as Earth, there are less effects from the solar winds. And when it is the same as Earth, it tends to put cracks in the Earth's magnetic field. And that's when you have greater experiences of the aurora borealis and the southern australis, because those charged particles from the sun, more of them are making it into the atmosphere than just the ones that are following the field lines and coming in at the poles. They're coming in through the cracks where Earth's magnetic field is weaker. And we're in one of those 7-year cycles right now where we have greater disturbances from the solar winds than when we don't. So I find that pretty interesting. So, Jorge, what we went over was the one assignment for this week. I showed a bunch of the links from the document, the phenomena waves document. I showed that on another computer and I pointed this screen at that, so it wasn't great, but I can't share the screen on YouTube. I would have to do Zoom in order to do that. Does anyone have any questions about the assignment? The last assignment is due Thursday, and then the extra credit, the bio, is due on Friday, and Friday we'll be doing the Zoom celebration. So I've already posted the link for that in Google Classroom. Are there any questions? And I'll say goodbye, and I'll see you Friday at 2 o'clock for Zoom if you want to celebrate with your classmates. Bye. Bye, not Eric. Bye, Jorge.